So I added these questions on our review because they're kind of things that were missing. And I just want to go over really quick the big picture, what we covered in these first 9 days or so. We started out with sig figs and then keeping track of them in multiplying and dividing, right? Or adding, subtracting. We got to keep track of the sig figs and calculations. We went on then to conversions, right? And I gave you pretty much all the conversions except for all the metric ones. You had to know the metric ones. And then we went on to something like this where, we get the mass of the fragments of the isotopes and their fractions in nature, their abundancy, and you can get the molar mass out of that. There is a lot of naming, right? We did a lot of naming. We worked with balancing, and pretty much all we did for balancing is there's so many different ways to skin that cat, but there's hard ways and there's easy ways. For example, when I look at this one, I see oxygens everywhere, so I balance it last. Way too complicated to start with oxygen. We introduced the concept of molar mass, and we converted from moles to grams, grams to moles, and we did a lot of dimensional analysis questions like those. We had, like today's quiz, we have a compound, and they give you the percent composition, and then they give you the molar mass. You had to figure out what the molecular formula was. We had questions like, again, a molar mass, but here, keep track of the sig figs. Report your answer to 3 sig figs. We did calculations where, hey, what's the mass of one single molecule, one single unit? We did stuff like that. And density always seems to be confusing, so I threw some of those in there. And then a lot of the same stuff over and over again. So we start at the very top. I think we should start. Advantageous to start at the top, even though you might be interested in jumping down to the middle, someone might be, is then pretty much every class leaves off the same spot, and it really helps out the pizza help session a lot. So I think it's good just to start at the top. So that's where I prefer to start. So let's just start there. Before we start doing this, though, let's remind ourselves about sig figs. Annabelle, how many sig figs in this first number, 934? 3. How about in the next one, Melissa? She counts 4. Everybody agree? If you're never sure, write it in what notation? Scientific notation. 4.350 times 10 to the negative 3. There's 4, right? These zeros disappear. Okay, so that's pretty much recognizing sig figs. But sig figs and calculations, Allison, we had 2 things to worry about. If we were multiplying, right? Let's just do this in our calculator. If you're multiplying, you had to report your answer to, do you remember, Allison? She's remembered. The measurement with the least number of sig figs. So I'm going to do this on my calculator. 934 times 0.00435. Okay, I'm going to write down all the digits, because if you remember doing these, you can't do any rounding until the very end. 4.0629. Now, Allison said, Katrina, that you report your answer to the one with the least number of sig figs. So, and we did that by underlining something here. What did we underline? What should we underline here? She said, report your answer to the one with the least number of sig figs. 4.06. Exactly. So what we did is we just underlined it. Because you can't do any rounding till the end. Everyone with us so far? Okay. Then you have to add on, Alejandro, 107. Adding and subtracting had a different rule. You report your answer how? When you're adding or subtracting. Multiplying and dividing was you pick the one with the smallest number of sig figs. Adding and subtracting, anybody remember? What'd you do? fewest decimal points, kind of. That's one way to look at it. I look at it as fewest decimal points, exactly right. This guy worked hard, 100th place. This guy, he didn't give a crap. He only did the ones place. That means if you add or subtract a number like this to the ones place, everything below the ones place is crap. It's gone. It does no good at all. Because he only measured to the ones place. You have no idea what's over there. So you have to report your answer to the ones place. You can't go anything beyond it. Make sense? So you have to do it all in the calculator. Plus 107. Yeah, you write it all down. You can underline the 7 if you want. But 111.0629. So that's, what would you report, say your answer is then? 111. Or 1.11 times 10 to the 2. Same thing. Okay. Do this one. Try that one. Try H. Jonathan, how did you report your answer right here? Hopefully you did this and you got 0.16. But what numbers should we underline here? So I just wrote down 0.16 because that's what it said in the calculator. Could be a bunch of zeros there, but. Well, you could write 1.6 and 10 to the negative 1, but yeah, just 0.16. Why do you underline the 6? Just 2 decimal places. He went to the second one. He went to the third. You got to go to the worst measurement. So underline the 6. So there could be more digits. There could be more digits here. Fine. You just have to write them down if they were there, but they're not there. Then you multiply it by 6.03 times 6.03, and I got 0.9648. Okay, Erica, you report your answer as what then? 0.96. Everybody agree? 3 sig figs, 2 sig figs? Ah, excellent. 0.96. Or 9.6 times 10 to the negative 1. Right? Okay. These conversions, again, I think one thing happened by accident today, and I think it worked out really well. I said, really, if you do not see how to start these out right away, like right off the top of your head, how many milligrams in a gram? How many deciliters in a liter? How, just pick it. If you don't know like that, when I get, if I were you, I probably didn't remember that stuff that quickly. Right when I get that exam, I would write all that stuff down. I'll pick them. millimeters, meter. What else was there? There was centimeters, meter. What else was there? Decimeters, millimeter, decimeters, meter. I'm just doing everything in terms of meters. We're missing one. Kilo. Okay, so you write this up in the corner of the exam, and you put in the numbers. And remember, the number always goes with the prefix, except for kilo. Right, okay. So that means you better put a number right here. What's the number? 1,001. You better put the number right here. 100. 10. 1,000 with the meter, right? Because the number goes with the prefix all the time except for kilo. Oh, I can write a 1 there. Boom. So if you put this up in the upper corner and just realize meters can be anything, grams, liters, seconds, who cares? Slugs, can be anything. And then you start working some of these. Try this first one. And you convert it to the right number of sig figs. Try this first one. And give your answer to the right number of sig figs. Okay. Oscar, what did you do first?
After we set up the
Right here.
oh,
Yeah.
So obviously write down 14.89 milligrams.
Yeah.
Then right on top 1 gram, and then on the bottom 1,000 milligrams.
Yeah. See? You hear him? He's exactly right. Usually this is how I start out. And it leads right to what Oscar said. Because that has to cancel. Bless you. That has to cancel. You come over here. Bless you, my goodness. There it is at the very top. Just what Oscar said. 1,000 millis in a hole. That's why he did it. The answers are staring at you when you write this out. They really are staring at you. Okay? Then what did you do next, Daisy? Yeah, we got to get the grams to pounds. So you could do this and say, hey, do I know what numbers to put in there? I can't reach that high. We don't know grams to pounds, but we do know grams to kilograms. So let's erase the pound. And put in a kilogram. The numbers are staring at you. What do you put in there, Danielle? It's going to be this one. Yep. Exactly. Okay, Christian, now we're finally ready for what? The pounds. The kilograms and the pounds. Don't have it memorized, it's right here. 2.205. Okay. Everything on top multiply, bottom divide. And I have to give my answer to the right number of sig figs. Tegan, what did you give as the final answer for this? 3.283 times 10 to the negative, what'd you say? 5. And don't forget to write the pounds. Everybody agree? 4 sig figs? 4 sig figs. Good. Try number 2 here. Try number 2. Convert 0.00230 milliseconds. Seconds. Oh no, to kiloseconds. So Diana, where did you start? Yep. 2, 1 second. And you gotta keep going, Annabelle. Yeah. What's the unit on top? Kilosecond. Then look over here. Right? The 1 always goes with the kilo. 1,000 goes with the unit. Right? So you put the 1 there. Right? So writing this out, I think, will really help prevent some mistakes. Not only prevent mistakes, but make things a lot faster. Right? So divide by 1,000 twice. And then, Melissa, you gave a final answer of... You have a calculator? Well, you do it in the calculator, and this is what you get.
22.3 times 10 to the power negative.
Can I draw my box around that and move on to the next question? No. Good. How many sig figs are over here? 3. Calculator isn't going to keep track of that. You have to do what? Add a 0. Right? Very good. Question on converting? Know those metric prefixes. Okay. This one, I think, is a really good example of seeing a question and knowing exactly what to do. Because if you can see this question, know exactly what to do, you don't even have to read it. And you could be done in a minute. Right? Should be an easy 10 points. What is the game plan, Katrina, for something like this? Yes. Multiply the mass times the abundance. And then do what?
And then once you calculate all of them, you add them.
Calculate all of them, then you add them. Exactly. And then your answer had better match what, Alejandro? Because what we're after is, what is the identity of the element? So we just calculated the atomic mass, in other words, molar mass. She multiplied the masses times their fractions, added them all up, What does it got to match? It's got to match the molar mass up here. Now, what color are the molar masses in? Everybody. They're red. It has to match one of these. If it doesn't, you screwed up. Right? What'd you get, Christian? What's the final answer? Silicon. Anybody else get silicon? Jonathan got silicon. That means you should have got about 28.09 or something, right? Silicon. If you added them up, you got somewhere around 28.09. And you just keep looking until you find it. And numbers get bigger as you go down and across to the right. Okay. For naming, really didn't have a whole lot of, I guess there was some guidance. How would you name something like this? Jorge, how would you name B? B as in boy. Sodium oxide, or is it sodium, or is it sodium oxide, or is it disodium oxide? Which one is it? Or is it sodium 2 oxide? Are we getting even more possibilities in here? First, right? It's what? Sodium oxide. It's sodium oxide. When do you use monodi-tri? Yeah, when there's 2 nonmetals. Has to be all nonmetals. Right? Okay. When do you use Roman numerals?
Transition over that.
Exactly. When they're not fixed, they're in the middle. They're the transition metals. Group B. What's that? Oh, we forgot about our exceptions. Except for zinc, which always has a charge of +2. And aluminum, which always has a charge of +3. Good. Those are the exceptions, Daisy. Very good. Okay. And knowing things like permanganate, you just have to have them memorized. All right? Permanganate was, anybody know?
Amen.
Good. But you got to know the charge on it. -1. Okay. Balancing. We don't need to balance it, Jonathan, but where would you start? Because there's hard ways and easy ways. What element would you balance first in that question? What's that? Chlorine. I think that's an excellent place to start because it only shows up once on each side. You can't go wrong with it. That's what I would do too. How about something like this? Calculate the mass in grams of the following and give your answer to the right number of sig figs. Let's look stick with that. How do you do this? Erica, you remember? How do you do this? Yes, you're getting there. It's a conversion problem. It's a dimensional analysis problem. Okay. Does anyone know? Oh, good. Mol Fe. I think this is an excellent place to start. Before you even start thinking, this should just be habit. Right? No number. Just write Mol Fe down there. Okay? Then what? Grams are up on top. What had units of grams per mole? Or grams of iron per mole of iron? What was the word for it? It's up here, but what was it called? Well, atomic mass is correct if you're talking, atomic mass. Because we're talking about one element. But molar mass is just always works, right? Then you have to worry about the word, molecular weight, formula weight, all that. Just molar mass. Up here. Right? So all these red numbers have units of what? What are the units? Grams per mole. Right? And when we say grams per mole, like iron was 55.845, that really doesn't help. Because how does that fit in the question? If you write it instead, grams of iron, box, mole of iron, that's really what it means. That's grams per mole. But it's so much easier to use in the box, right? In fact, it's staring at you. You don't even flip it or anything. It works great. So that means the 1 on the bottom, 55.45 on the top. Report our answer to the right number of sig figs. I got 11.448. Way too many digits. Way too many digits, Clarissa. 11.4, let's see. Yeah, because there's 3 digits here, right? So she better report it to 3. That'd be 11.4. And don't forget your units, otherwise you'll get docked points, right? Don't just write 11.4. Try the next one. Try the arsenic one. Oh, good question. You always, Daisy, always look at the beginning. Whatever it starts on, as dimensional analysis questions, they always have these boxes, right? And things are canceling. Whatever the measurement is at the very front, however many sig figs are there, your answer has to have the same number of sig figs. So this one better have 3 sig figs, the arsenic question. And that's how I start every single one of them. See it. 74.9216. So what did you report your answer to, Daisy? What did you say it is? Well, just write it out. Write out what the calculator gave you. Okay, there's a lot, right? Okay. So, do you count the zeros or not? Write it in scientific notation. Then you don't have to worry about anything. This number written in scientific notation would be what? 3.4302, and you keep going, times 10 to the negative 2. Okay. A lot easier to see sig figs. How many sig figs over here, everybody? 3. So we report our answer just as 3.43 times 10 to the negative 2.
Or 0.0343.
Yeah. Or 0.0343. Right? Oh, and our units.
Go grams.
Moles of arsenic.
Moles.
I'm going to lose points already. Okay. These percent questions. Okay. I don't want to go through this question. Instead, I want to hit the spot where at least one person had a screw up in here. I know Danielle got it right, though. Remember, I'm going to ask Danielle, after you convert everything to moles, right? Convert all the grams to moles, and then we divide through by the smallest, and then you get these numbers, right? And if you got let's just do what the quiz said. The quiz ended up with a 1.5. Right? Usually we can do some rounding, but Danielle did not round. I don't think she did. Oh, she did. You did round. I thought you multiplied by. Oh, Danielle. Okay, Tegan got it. You got a 1.5 and a bunch of other numbers. So what did you do? Multiplied everything through by 2. Right? All the numbers you got times 2. So for me, for this type of question, you just got to remember these funky numbers. After you divide by the smallest, you can end up with 1.5. What was another one that caused a problem? 1.125. What was another one? 1.25. There's one more. 1.3. Okay. If you have 1.125, you have to multiply everything by 8. 1.25, 4. 1.3, 3. Yeah, just remember those. So after you divide by the smallest, be careful of your rounding. If you end up with any magic decimals there, any of those 4, make sure you multiply everything, all the moles, by that whole number. Okay, let's try this one. Find the molar mass to 3 sig figs of CO2. Bless you. Find the molar mass to 3 sig figs of CO2. Okay. Now you remember how to get molar mass? Add up the molar masses of 1 carbon and 2 oxygens. Right? And everything's up here. Everything's on that periodic table. But don't do any rounding to the very end because they're worried about sig figs. Right? Don't do any rounding until the very end. Annabelle, did you get 44.0095? No? So 1 carbon
Yeah.
plus 2 times oxygen.
I know I did wrong.
Okay. So anybody who got 44.095, what do you report your answer to? 3 sig figs. You agree? 44.0? Yeah. But you need units. Grams per mole. You can grams per mole works, but preferably to help you out, right, in all these dimensional analysis problems. But grams per mole works great. Okay, one last question, we'll let you go here. What is the mass of a single CO2 molecule? There's a cheat. There's a trick to do this. Anyone remember what it is? Divided by Avogadro. Here's a guide, if you don't remember it. Here's 5. Let's say chalk is the Smith element. This is an atom of chalk, right? I find the mass of 5 of them, and I put that 5 right here for molar mass. If I want to find the mass of one of these chalks, I would just divide by what then? By 5, right? Because if I had 5 of them, and I wrote down the mass of 5 of them, I want to find the mass of 1 divided by 5. But you have a lot more than 5. It's Avogadro's number. So you take these, to find the mass of any individual unit, whether it's a molecule or an element, what's the mass of a carbon atom, for example, always take the molar mass and divide it by Avogadro. But to make this work, you got to know what Avogadro's number is. 6.022 10 to the 23rd. Very good. So you're pretty much you're halfway there. You have the molar mass. Just divide it by Avogadro. And you get like 7.31 times 10 to the negative 23. But you need units, though. Grams. Grams of CO2 or something. Very good. So hopefully we'll see you Thursday if you can make it. If not, don't worry. Nothing new is introduced.
7.30 be accepted.
They didn't care about sig figs.
Oh.
So it really doesn't matter.
But would it be acceptable?
Yeah.